Okay, so today we talked about transformations, and up until this point in time, we've been dealing with standard form, where we have ax squared plus bx plus c. But at this time, we're going to start to focus on a different type of form called vertex form, where, you guessed it, the most important part of the graph, the vertex, can be easily identified. Vertex form is going to be y is equal to a quantity x minus h quantity squared plus k. And in this variable case, our vertex is going to actually be h and k. And you can read it, any equation that's written in vertex form, whether it be given to you, you can say vertex hk, there it is, and we can also identify the axis of symmetry as x is equal to h. Okay, looking at the transformations, I like to first focus on k. It's kind of hanging out there on the end, and it's the easiest one. It moves the graphs up or down when compared to the parent graph, and we call these vertical shifts, up or down. And as you can imagine, positive moves our graph up and negative moves our graph down. Focusing now on the h, you'll notice it has a negative h, or when we talked about the quadratic formula, the opposite of b. Same thing here, it's the opposite of h. So under normal circumstances, when you're thinking about the coordinate xy graph, and you're thinking about left and right horizontal movements or horizontal shifts, normally you say, okay, the negative values are to the left, the positive values are to the right. Well, when we're thinking about the opposite of h, it's actually going to be the opposite of what you think, just like with the opposite of b. So when we're talking about left or right, to the right is actually going to be any negative h values, and to the left will be any positive h values. Looking at the front of the equation, we've got the negative out there in the front. It's dotted because sometimes it appears and sometimes it does not. Any negative a, and we've talked about this before when referring to standard form, is going to reflect over the x-axis. This is commonly referred to by most students as flipping the graph. It actually flips the graph upside down completely. And that reflects over, through, or about the x-axis. Looking at the a value sitting outside of the parentheses in the front of the equation, we must focus on the absolute value of a. We really have already accounted for any negatives that may appear. So when we're talking about what does the a do, we need to focus on the absolute value of the a. And what we're looking for is a greater than 1, or is the absolute value of a less than 1. If the absolute value of a is greater than 1, it does what we call a vertical stretch. Both movements up and down, as well as the a value, are referred to as vertical. Vertical shifts up or down, in this case, vertical stretches. And if a is less than 1, they are vertical shrinks. Both of which then are followed by a tagline of by a scale factor of, and you can abbreviate it SF if you want to. And that's by a scale factor of whatever the absolute value of a was. So K's move us up and down, positive up, negative down. H's move us left or right, where positive moves left and negative moves right. Any negative value in front of the A reflects us, and the A, if it's greater than 1, is a vertical stretch. If it's less than 1, is a vertical shrink. Looking at your homework here, we know the directions say using your graphing calculator, and if you go online, you can probably access one through Google, but you don't need to do that. We can use our table right in our regular multi-view. And it first starts off by asking you to graph the parent function, y is equal to x squared. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and then graph this new function, y is equal to negative x squared. And I've used my Word document here to cover up, and we're trying to figure out what does that negative do. Well, again, when you punch into your table, you get your coordinates. 0, 0 is still your vertex. 1 will go to negative 1. Negative 1 will then correspond with negative 1 again. 2 will go to negative 4, and negative 2 will go to negative 4, showing us that any negative x value will reflect over the x-axis. Looking at 5 and 6 here, go ahead and just graph those, x squared plus 2, and you can see we're focusing in just on comparing it to the parent graph, that each coordinate point, the 0, 0 vertex, moves up to 0, 2. 1, 1 moves up to 1, 3, and so on. Looking over at y is equal to x squared minus 4, you can take each of those points and shift them down 4. 0, 0 goes to 0, negative 4. 1, 1 goes to 1, negative 3, and so on. So what does a number out there on the outside do? It says moves it up or down. In the case of number 5, up 2. In the case of number 6, down 4. All right, looking at 17, 18, 19, and 20, I've added some more Word docs here to kind of cover things up, and I think it might be easy for you to just focus just on just the k's hanging out here in the end. What does the positive 5 do? What does the positive 7 do? What does the negative 2 do? What does the positive 8 do? And then I've shifted them again here to say, okay, now we're looking at just the inside, the opposite of h. What does a negative 3 do? Remember, it's opposite direction. What does a negative 2 do? And then the same thing for the positive and negative 3's. And then again here, covering up and looking at just the a's. In the case of the top one here, that's a 1, so there's no stretching or shrinking going on. We've got a negative 1, a 1/3, and a positive 4.